Hello everyone. So we've decided to flip things around again. We're doing graphs of linear equations and I'm finishing this up. So we're going to graph horizontal and vertical lines and we're going to use our slopes to determine whether lines are parallel, perpendicular, or neither. Okay, so we're going to use our slope to help us graph. So in this particular problem it says what would we do for a line whose slope is 0 and a point on the line is 4, 3. So we have to think about the information that we received about slopes. Remember, if the slope is 0, that means we can walk along that path or we can ski along it. So that's going to be a horizontal line. We don't actually have the equation of the line, but we don't necessarily need that to plot the point 4, 3, to the right 4 and up 3, and then we're going to draw a horizontal line. And try to keep this on the line. There we go. Now remember that the equation for a horizontal line is y equals 3 because that vertical value never changes. So the y value is constant. So y equals 3. So now we have to think about what type of line has a slope that's undefined. And in the previous example, it has a slope of 0. And I talked about how you can walk across something that has a slope of 0. So with the slope being undefined, remember we're falling down that mountain. We got to a vertical drop on the mountain, so we can't ski anymore. So if the slope is undefined, then that's a vertical line. So we're going to plot this new point here, -2, 5. And this is going to be, here's the point, and it's going to be a vertical line. And I tried to keep it on the -2 spot, so let's just try to darken that in so it looks a little bit better. So without a straight edge on a computer, that's the best we can do. There's our vertical line along the point -2, 5, which means the x value never changes. This equation would be x equals -2. So now we need to learn about the properties of parallel and perpendicular lines. Lines are parallel if they have the same slopes and different y-intercepts. Lines are said to be perpendicular if their slopes are negative reciprocals of one another. So what does that mean when we say that they're negative reciprocals of each other? Let's say we have a line with a slope of -1/2. Then the line that is perpendicular, or the perpendicular line, has a slope, which we'll call m2, equaling +2. Because the reciprocal of 1/2 is 2, so the negative reciprocal would be +2. If neither of these cases hold true, then we say the line is neither parallel nor perpendicular. So here we have some examples of possible parallel, perpendicular, or neither lines. So we're supposed to examine the sets of equations below, determine whether they are parallel, perpendicular, or neither. So let's look at example 1. Example 1, if we look at this first equation, which is not labeled as y1, but we're going to label it as y1, and then we've got y2, the slope of y1 is this value here that is next to the x, so it's -3. The slope of y2 is this value here, the coefficient of x, which is equal to 3. So, are these two slopes equal? No, one's positive, one's negative. Are they reciprocals of each other? No, one's not a fraction of the other. So this would be classified as neither parallel nor perpendicular. Okay, let's look at our next one. Okay, once again, we did not label these as y1, y2, so we're going to do that as we're doing our notes. y1 equals 6x minus 5. So the coefficient next to the x is a 6. And then y2 equals 6x plus 1. The coefficient next to the x is another 6. So these two slopes are equal, telling us that these two lines are parallel. And example 3. Here y1 is equal to 3/2 x minus 4. So the slope is 3/2, and y2 is equal to negative 2/3 x minus 8. So m2 is equal to negative 2/3. Notice that in none of these examples have I written down the x. The slope is the coefficient next to the x. So one of these is positive, one is negative. 3/2, its reciprocal is 2/3. So these lines are perpendicular. And we could use symbols to identify perpendicular, which perpendicular is an upside down T. I didn't use the symbol for parallel, but we'll go back and add that in. It kind of looks like two slanted lines. Oh, now this one requires some work because this doesn't say y equals for number 4. So I need to add 4x to both sides. Then we have y equals 4x plus 2. So this is going to be my y2, this is my y1. Now, y1 equals 4x plus 2, y2 equals 4x plus 2. So slope 1 is 4, and slope 2 is equal to 4. However, these are actually the exact same line because the y-intercepts are not different. So these are neither parallel nor perpendicular because it represents the same line. It's the exact same equation. Okay, hopefully everyone got those okay. So we can come up with our own lines that are perpendicular or parallel to a given line. And to do this, we first have to identify the slope of the original line, which would be the slope of a line that's parallel, and the slope of the negative reciprocal, which would be the slope of a perpendicular line. Remember that slope is rise over run, rise being the y values and run being the x values. So if we look at this first graph, we have a point here. We always want to find where it's at the intersection of the grid lines. So to find this slope, we're going to go up 1, 2, 3, and then we go right 1. So the slope of the first line is positive 3/1. Now, the perpendicular slope is the negative reciprocal, which is negative 1/3. Looking at this next line, here's an intersection point, and here's another grid line intersection. So this time when we rise, we're actually going down 1, 2, and then to get to the point, we go right 1, 2, 3. So the slope is negative 2/3. And the perpendicular is going to be positive, which is the negative reciprocal, 3/2. Oh, here we have a vertical line, so there's not much counting involved. The main thing to remember is that the slope of a vertical line is undefined. So therefore, the perpendicular line would be a horizontal line which has a slope of 0. So this required you to use your recall knowledge of that particular type, those particular types of lines. Okay, so let's remember how to find the domain and range from a graph, because we're going to revisit this. Some of the problems in the book are not as extensive as we'd like them to be. So remember that the domain is the direction horizontally, x and y. X only. And range is vertical, that's the y values. So if I look at this, this goes over here. This is as far as this graph goes to the left. Well, that's in between 0 and -1. So I'm going to call that -0.5 or -1/2. And then it does actually exist there, so we're going to put a bracket. And then where does it end? Well, it ends over here on the other side where we have an x value of 4. Remember, we're looking right here at this x value. Now, it does not include that because it has the open circle. So at that point, we have to have a parenthesis for our domain. Now for the range, we're looking at how far down does this particular graph go. Well, it goes to here, which is -4 on our y-axis. However, it has that open circle, so it's not included. And then we go all the way up here to +1, so that's where it is on the y-axis. And once again, it's an open circle, so we're not including that. So this would be our domain, -1/2 to 4, and our range is -4 to 1. And now let's look at this other graph. This graph does go on forever to the right, so we know that this is going to be positive infinity. And yes, I kind of started on the other end, because here I needed to do a little bit of thinking. So this is a -5. And it's got an open circle, so it also has parentheses. So our domain is from -5 to infinity with parentheses on both sides. Well, this same point is also the lowest spot on the graph. So in terms of our y values, that's -4. It's still that open circle, so we don't include it. And then once again, this arrow is telling us that it goes on forever. So that's positive at infinity for our maximum value for the range. In other words, it never reaches the maximum value because it's infinity. So that covers our domain and range, again, as a review.